What's up, Science 9? This is Mr. Yago and Hizzy. I'm gone today, as you can see. I apologize. But I wanted to still go through our last notes section. This is on light. It's still a section of physics. But I just want you guys to get a couple things down today in your notebooks. So let's get started. So today's focus is going to be, what is light? And light is simply a name for a range of electromagnetic radiation that can be detected by the human eye. So yesterday, you guys watched a couple YouTube clips of the variety of things that you would see on what we classify as the electromagnetic spectrum. And there are some certain variables that are explained kind of in this section. But first and foremost, we understand what radiation is. So when I say that it's a range of electromagnetic radiation, or EMR, we are talking about a type of energy transfer that does not require matter. Okay? So for instance, when you go into space, and remember how I said that if you were to talk, you could not hear sound. Okay? Because sound relies on matter. Matter like air molecules in the air, like oxygen and nitrogen and carbon dioxide, to vibrate through. Okay? Just like you were to hear things underwater. All right, it's a little different, but water is obviously a molecule, a chunk of matter that you could hear through. Now, radiation does not require that. Okay, so think about this. Radiation could be from the sun, solar radiation. That is going to travel through space, hit Earth, and heat up. Okay, now, when we talk about the electromagnetic spectrum, there are a variety of things that radiate. Okay, whether it's radios, microwaves, infrared radiation, ultraviolet, visible light, which we'll talk about in greater detail, X-rays, or even gamma rays. And we look at the scale, we're going to talk about a couple main words today: wavelength, frequency, and then energy. All right, so we'll get into a little more explanation on how this spectrum works in your life. So let's get started. This right here is a radiation wave, okay? And I hope you can make some observations here. We talk about wavelength, and you may want to draw a picture in your notes that kind of shows this, but wavelength is essentially the distance from one wave to the other. So this distance right here from what we classify as the crest would be your wavelength, okay? So let me get a little bit better drawing on here. So this right here, this distance is classified as wavelength, okay? So radio waves should have a large wavelength, where gamma rays should have a very small wavelength. I'm writing with my fingers, so I apologize for my handwriting. So that basically means that, you know, the wavelength should correlate to something. And usually what that correlation is that the shorter the wavelength, so something like gamma rays, the more energy that you have. Okay? So when we look at, you know, an X-ray versus a microwave, X-rays have a much shorter wavelength. They have much more energy than a microwave does. Okay? Now another thing that we're going to look at here is frequency. All right, so frequency deals with how many waves occur in a given amount of time. Okay, and we usually measure frequency in something called hertz. Okay, so you can see right here, this is hertz. We measured wavelength in meters. So if we look at a section here, for instance, this section right here, I see maybe one wavelength, 2 halves. And this one I see about 1.5. This one you can clearly see there's 1, 2. This one is 1, 2, 3, and you get the idea. As we get out to gamma rays, it's like 1, 2, 3, 4, 5, 6, 7, 8. So the frequency is the amount of waves of radiation that you get. So it would make more sense that radio, longer wavelength, less or small frequency, less energy, whereas gamma rays are going to have shorter wavelength, higher frequency, and they're actually going to have a little bit more energy. Okay. Now, last thing I'll talk about is the visible spectrum. This visible spectrum is responsible for anything that we see. So any light that we see with our eye is seen in this really small section called the visible spectrum, okay, the radiation. So it gives us all of our colors, as you can see here, which means that we can't see UV rays, we can't see infrared, we can't see X-rays, we can't see microwaves. You don't look in the microwave and go, oh, I can see all these little waves. We can't see this stuff. The only thing we can see is this small little sliver. Okay. Underneath, we give an idea of the size of the wavelength, just to give you more of a height. Radio waves can be as tall as buildings, okay, whereas gamma rays can be as tall as atomic nuclei, which is really small. Okay. Now, as I mentioned, light travels in waves. These waves would be classified as transverse waves, so waves that you would maybe see in a pond or a lake are transverse waves. And we know that they transfer their energy by radiation. Now, transverse waves are a type of wave where the medium moves at right angles to the direction the wave is traveling. So something that would be a medium would be air. Okay, so we would have air, we could have water, and we can have solid objects. Okay. Those are all considered a medium, okay? Now, a transverse wave means that whenever it hits that object, it's going to move at a right angle to the direction the wave is traveling. Not 100% important that you know that, but the big thing is that I want you to know is that it needs a medium to travel. You need to have air, you need to have water, you need to have a solid object. So, light and color. The type of matter in an object determines the amount of light it absorbs or reflects. So opaque materials would be something that absorbs or reflects all light. You can't see through them. So maybe an example would be a wall, a door, something of that nature. But opaque materials are something that basically absorbs or reflects all light. It is impossible to see through it. Now, if we get into transparent materials, this type of material allows light to pass through completely. So I always think of from my high school and educational days, we had transparencies, which is that kind of thin piece of plastic. You can see through it, you can write on it and see through it. That would be transparent. A window would be transparent. Something that's translucent, the material that can be seen is very hazy, meaning it's not outlined very well, but you can allow some light to pass through it. So I always think of maybe like the window that you have in your bathroom. The window that you have in your bathroom, you can see an image through it, but it's very hazy. You can't necessarily pick out what it is. You can maybe see the outline or the halo of it, and that would be classified as a translucent object. So light can go through, but you can't see the objects. Transparent, light can go through, you can see the object. Opaque, no light can go through, definitely can't see the object. So, why are objects colored? Well, color objects appear due to the visible spectrum, okay? So all light, or what we classify as white light, has Roy G. Biv. So red, orange, yellow, green, violet, Roy G. Biv. Blue, indigo, violet, sorry. So all white light contains all of the necessary colors that you need. And when it hits an object, it's going to absorb everything but that color that's being reflected. So for instance, we have a green leaf. That means when light hits it, everything but green. So Roy, Biv, not the G. So red gets absorbed, yellow gets absorbed, violet gets absorbed, but green is reflected. Okay, so for instance, blue jeans reflect blue light. What do they absorb? Ask yourself that. Hopefully you're answering in your head that they absorb everything else but blue. Black objects absorb all colors, and they don't reflect any light. Okay, so black is actually the lack of color. All right, whereas white light reflects all the colors. So, for example, if it's like wintertime and you want to stay warm outside, we usually tend to wear black clothing because it absorbs all of that sunlight. It's not only a colored light, but there's also radiation. There's energy in there. So, whereas white light is something you want to wear, or white would be something you want to wear more in summer because it will reflect all of those colors that are in the rainbow here, and kind of keep you cool. So, how can we go about filtering this? Well, a filter is a transparent, Okay, material that transmits one or more colors of light but absorbs all others. So the color of a filter is the same color of the light it transmits. All right. So if we have a green filter and you put white light through, you're only going to see green light. All right. So filters are used to basically emit the color that you want to have. So what are our colors? Well, in art it's a little bit different, but in light our primary colors are red, blue, and green. But they can be combined to form any color. So however, all the primary light colors form white light. So what they're classified as additive colors. So when we look at these primary colors, they are what basically gives us everything that we need. So red, blue, and green will give us yellow, cyan, magenta, and also white would be made up of all that. So it's almost like 3 Venn diagrams here that really show you how these lights come together. Now, what about pigments? Pigment is a material that changes the color of the reflected or transmitted light as a result of a wavelength selective absorption, which means that a pigment is going to absorb specific wavelengths or colors and reflect the ones that you want. And there are 3 primary pigments. There are yellow, magenta, and cyan. Okay? When you add all 3 together, you get black. All right? So yellow, magenta, cyan, add them all together, you get black. Magenta and cyan make blue. Magenta and yellow make red. Yellow and cyan make green. Okay? And if you notice, if you've ever put an ink cartridge in a printer, you'll notice that cyan is one of those major colors, yellow is one of those major colors, and magenta is one of those major colors. Okay? So next time if you've ever replaced ink in a colored printer, you will notice that you will see these 3 colors involved in that. Now when you add all 3 together, as I mentioned, it is black. Okay? So therefore pigments are considered to be subtractive colors. Whereas on the previous slide, we talked about additive colors. So last but not least, we're going to get into a little bit of biology, my bread and butter. How do we see this? Now, obviously here we have an eye. And in the back of our eye, so when light goes into something called the pupil here, it goes into basically like a projection screen. And on that projection screen, we are going to see, like if this is the back of the eye here, okay? So light's coming in. This is classified as the retina. Okay, so imagine this is kind of the back of the eye. All right, so this would be back here if light's coming in. On the back of the eye, we have a lot of these photoreceptors. Okay, and either they are rods or they are cones. Rods allow us to see black and white. Cones let us see colors. Okay, now some people are missing cones, which would give them a form of color blindness. Nice, I got a sneeze in the vid. That's awesome. Anyways, my apologies. So when we bring light in, dim light will be seen using those rods, which are specific little neuro devices. So it's going to send a signal, and that's going to go up to your brain. And then you're going to interpret that image. And then the cones will allow us to see any type of color. All right? So we have an idea of what light is. It's radiation. It's transmitted by transverse waves. We have a variety of colors that we can see visibly, Roy G. Biv. We look at colors in our environment, in our world. Any color you see is a color that is being reflected. All of those other colors of Roy G. Biv that is not being reflected is being absorbed. Okay? And we can see that due to things like cones, which allow us to see those colors. So I hope we learned a little bit about light today. You're going to be doing an activity tomorrow where you look at this colored light and how it enters your eye and how we filter it and how the pigments are involved. So hopefully you get a really good understanding. Remember, this is our last section of notes as well as our last section of physics. And that will end our unit. We are not going to have any sort of quiz on light, but it will be on our final exam. So hopefully you took good notes, and we'll get an opportunity to wrap this up tomorrow. Have a great day. Thank you.